to start our lesson today. Grade 7 maths. And of course, if you have any further questions or clarity-seeking questions or comments regarding the lesson, please feel free to follow me on Twitter account at Hendrik Makane3. And by the end of this lesson, I want our learners to be able to now calculate the perimeter of regular and irregular polygons, but also to use and convert between appropriate units, which we are going to work with a lot as far as the polygons are concerned. Right, yesterday we spoke about the area of a rectangle and we have defined the area as follows. We said that the area of a rectangle is equal to length times breadth, and that was the discussion of yesterday. But we equally discussed, the various points there which can be used when you calculate the perimeter. And we said that the perimeter of a rectangle is given by the formula L plus L plus B plus B. Basically, you need to add all the sides together, and this will give you the perimeter of a rectangle. Now, today, we are going to focus on the perimeter of any polygon. But before we get there, yesterday I gave you this homework. I said we must calculate the perimeter and the area of rectangle ABCD. Can we mark this homework quickly, just in the next 3 minutes? Let's calculate the perimeter of rectangle ABCD. You are given the side AD, which is 7 centimeters, and the side AB, which is 9,3 centimeters. So can we find the perimeter? I've just shown you the formula to calculate the perimeter. If there's anyone who wants to try and answer the first one, calculate the perimeter of the rectangle. I'm ready for you. Anyone at all? Mulalo? Mulalo.
For A.
Yes. What is the perimeter of the rectangle?
The answer for A is 32.20 is 32.26.
Okay, 32.26.
26.
Yes, 32,6. How did you find it?
So I did the method of I did 9.3
Yes.
plus 9.3.
Yes.
Then after that I did the same for 7.
Okay.
Then I plus the answers together.
Exactly. That is the correct approach. So you can add 9,3 together with 9,3, and then 7. You can add also 7 and 7. And you say you found 32,6, I believe. That should be the right answer, 32,6 centimeters. Right, calculate the area now of the rectangle using the formula. The area would be what will be the area of the rectangle? The area of the rectangle will be length times breadth. And what is our length in this case? The length is 9,3 centimeters and the breadth is 7 centimeters. Now you multiply those together. And as you can see in the next slide, where I've shown you how to calculate both the perimeter and the area. The first one is, you are correct when you say 32,6 centimeters. And the next one, of course, which is the area given by A, is equal to L multiplied by B. And of course, L times B gives you the length of 9,3 times 7, which gives us 5,1 square centimeters. Yes, Togozo? Togozo? Togozo, are you there? Right. Let's carry on now. We are now proceeding to define the perimeter of a polygon as follows: the sum of the lengths of the sides or the distance along the side of the shape. I usually call it the edge. So the definition of a perimeter for any polygon has not changed. It is still the same. So it will be the distance along the sides of the shape or the sum of the lengths. Or alternatively, you can call it the sides. If you add all the sides, then you should be able to get the perimeter. And of course, a regular polygon. I'm just going to distinguish between polygons. We have a regular polygon and irregular polygon. That is what the lesson of today. The regular polygon and an irregular polygon. And what is the difference? Well, a polygon which has got all angles which are equal, in other words, an equiangular polygon, as well as all sides which are equal. We say equilateral. That kind of a polygon is called a regular polygon. And of course, this is the example of regular polygons. As you can see there, we have a triangle which is an equilateral triangle. We also have a square. You can see that in a square, all sides are equal. But equally, we have a pentagon, which is a 5-sided figure there. And of course, the sides are also equal. The small lines that you see there in each side means that those sides are equal. But if you also look at the angles, the triangle, you can see that all angles are equal, which means our polygon there is equiangular. In that case, it's a triangle which is equiangular, but it's also an equilateral triangle, meaning that all the sides are equal. And all the angles are also equal, meaning that is your equiangular. The same goes for all the other sides. Make it the point that you also focus on the angles and not only the sides. So the angles and the sides must be equal. So all angles of a polygon must be equal together with all the sides. Now we are going to define an irregular polygon. An irregular polygon does not have equal sides or all angles that are equal. So in an irregular polygon, not all sides are equal, and not all angles are equal. We are talking now about an irregular polygon. And the example is as follows. You can see that we have got about 4 polygons there. And we are saying that they are not regular. Why? Look at the first one, which is a rectangle. It has got a length and a breadth. So obviously, all 4 sides are not equal. Although the angles are equal, but the sides, not all sides are equal. You only have a pair of equal sides. The length is equal to the other length, as well as the breadth, 2 pairs of equal sides. Although the angles are equal, the sides are not equal. So therefore, this is not a regular polygon. We say that it's an irregular polygon, opposite of regular. And of course, if you also look at the triangle, it is the same. Even with the triangle, you can see that it is not a regular triangle because two sides look or seem to be equal there. This looks like an isosceles triangle. You've got the shortest side and you've got two long sides. So this two is not a regular polygon. So I just thought that I must distinguish between regular polygons and irregular polygons. Just to recap, going back, you can see what a regular polygon looks like. Regular polygon, all sides equal, angles are equal, as opposed to an irregular polygon, all sides are not in an irregular polygon. And of course, even angles at times, not all angles will be equal in an irregular polygon. Right. Without any waste of time, I want us to remember that in the same way that we have applied the definition of a perimeter to determine the perimeter of a square, the perimeter of a rectangle, as we did, or irregular, you use the same principle, meaning that let us proceed. And I want you to calculate the perimeter to Fikile Shabangli.
The polygons and the.
And I'm going to
Yes,
start with a regular, could be a pentagon. You know, now we are saying the polygon where all angles are equiangular, we're referring to the sides, equilateral. So of regular polygons. I've given you this is a regular polygon. All angles are also equal. Pentagon, 5-sided, they've got 5 sides. This pentagon is a regular polygon, as well as the examples. Now let's go to does not have all equal sides. Obviously, not all sides of the rectangle there, which looks exactly like an isosceles triangle, then it must be an equilateral triangle. In the regular one, I've already defined it. Both regular and irregular polygons, you should be able to define. So it doesn't matter whether a polygon is regular or irregular. The perimeter, you use the same to calculate the perimeter of this polygon. Mamukata?
The perimeter is gonna be 2 plus 2.
The perimeter of this polygon, you will add side is 2 centimeters. Now 8 centimeters. So yes, see, the answer is P equal to 2. Does it make sense? A 4-sided, 2 centimeters each, 2 plus 2 plus 2, which is 8. Polygon. Yes, all right.
And then she texted it out of me when I come back.
Carry on.
Okay, so 5 plus 4 will give you
the background to please make sure that you are correct when you say you will add the 2. 2 will give you 14, the perimeter of the polygon, and of course calculating the perimeter there as well. I'm just going to give us plus 5 plus 2 plus 5. So it's really so definitely will come to 40 makes sense for all of us as we proceed to the next example. We have another irregular polygon, and we need to find the perimeter, the sides. One of the sides is 31. Jason, let's go to you. Lita.
128.
Go ahead.
Razor, would I get out?
Can you please proceed?
128. 8.
Yes, 128. How did you get it, Lita? Much appreciated. Before we go to measurement, so obviously you add all four sides and 28. So you'll add 1 plus. Before we wrap up the topic on the perimeter polygon, this one is a square. Let me skip you for now, Lita. We don't seem to find all the hands. Busi, can you hear me? 6,4. Jason? 4 sides, 1,6 plus 1,6 plus 1,6. As you can just see, the final answer there. So I think we've exhausted the topic on perimeter. Remember of a rectangle, and of course, you know, to remember that a perimeter of a polygon is how we define it. We have also defined irregular polygons. We said that those are polygons equal. So the polygon must be equiangular. Not all sides are equal, not all angles are equal. Of time, I want us to zoom directly. We're going to use and convert between the appropriate units, which include the square millimeters as well as the square centimeters. So in other words, we need to learn how to convert from millimeters or square millimeters in this case, centimeters. Equally, we must convert to from square centimeters to square meters. So this is something that you're going to work with in as far as these polygons are concerned. So you need to know how to use and convert between appropriate units. Now, here's an activity. I want you to count how many millimeters make 1 centimeter. Or 1 centimeter, how many millimeters are there in 1 centimeter? How many millimeters are there in 1 centimeter? If you have a ruler, you can check. Just check it. Right. I'm just gonna recognize you now. I think that we'll go to, I wanted to go to Ubakeng. Let's go to, I see that there are a few hands now. Let's go to, I see Tab, X. I don't think that's your real name, Tab. X. Right, let's go to Bella. Bella,
So can you hear me?
I can hear you.
There are 10 millimeters in a centimeter.
There are 10 millimeters in a centimeter. Right. There are 10 that make up 1 centimeter. Now, 1 centimeter, sorry. Now, I want you to count how many centimeters make 1 millimeter. How many centimeters make 1 millimeter? So we have now reversed the odds. Let's go to, let's see. All right, I don't see any hands now. It looks like we have a few hands. Can we go to superstition? Specific. How many centimeters make 1 millimeter?
1 centimeter.
1 centimeter.
Yes, sir.
Okay. Okay, just hold it there. So you say 1 centimeter makes 1 millimeter.
Yes, sir.
Okay, how many millimeters then make 1 centimeter then?
10.
10.
Yes, sir.
Okay, so 10 millimeters make up 1 centimeter.
Mm-hmm.
So how many centimeters make up 10 millimeters? One. I'm
One.
sorry, it's 1. Okay.
Yes, sir.
So how many now? How many centimeters make up just 1 this time? 1 millimeter, not 10. Think about that. I'll give you a chance to think about it. But at the
Yes,
same
sir.
time, I want you to count how many centimeters make 1 meter now. Now
Yes,
that's
sir.
the third question. How many centimeters makes 1 meter? And the last one, how many meters makes 1 centimeter? So that's the last question there. Just think about it. Right.
0.1 centimeter makes 1 milliliter.
Exactly. So 0.1. How do you find 0.1? Divided 1 by 10, isn't it?
Yes, sir.
Yes, so that will be 0.1 centimeter, which makes up 1 millimeter.
Millimeter.
Now count how many centimeters do you need to make just 1 meter. How many centimeters?
0.1.
0.1 centimeters.
Yes, sir. Makes 1 milliliter.
No, yes, that one is fine. You have answered number 2. That's correct. When it says 0.1, I agree with you. I'm now in the third question now. Now the third question says, how many centimeters make up the 1 meter? Let me go to another learner now. Let's go to Nikiwe. Let's go to Niki. Niki? You want to try? All right. I think we'll have to now go to Arnold quickly. Let's go to Arnold. Arnold, can you give us the answer for the third question? How many centimeters makes 1 meter? Are you there, Arnold? All right, then the last person is Lisa now. Lisa, we are back now with you. How many? I think you have worked it out now. How many centimeters make up 1 meter?
I've not opened the great package to me now.
Lisa, are you there? All right, let's mute Lisa there. And of course, you know that we obviously, a ruler is the correct measurement that you can use to find 1 meter. If you look at the ruler, you know, it has got about 30 centimeters. Now, I always give this example that if you take 3 of those, it will definitely give you 90, you know, 90 centimeters, and you'll be left with 10 centimeter to complete 100. Now, 100 centimeter will definitely give you 1 meter. So that now will be the third one. So always make use also of your ruler just to check, because the measurements are there, they are very clear. If you are not sure, you know, without relying on the table. I know some of you rely on the tablet or on the computer to Google. It's not a nice way of learning how centimeters work or learning how to convert from centimeters to meters. You must also use practical examples. You know, you make use of measurements to calculate. Now the last one is calculate how many meters make 1 centimeter. So it's basically the opposite of the previous question. That means you have to divide now by 100. And of course, if you divide 1 by 100, you'll get 0.01. So 0.01 meters will make up 1 centimeters. As you can see in the solutions that I have, the first one, of course, which was answered correctly, we said that 1 centimeter is equal to 10 millimeters. And of course, I think it was Lita, if I'm not mistaken, who also answered that 1 millimeter is equal to 0.1 centimeters. And as I've just given you now, 1 meter will be equal to 100 centimeters. So if you look at your ruler there, the normal ruler will have 30 centimeters, and the other side, of course, will be 300 millimeters. But if you take the centimeters, you need about 3 of those to go to 90, and you have with 10 centimeters to reach a meter there. So 1 meter is equal to 100 centimeters. And of course, the last one, which is the opposite, you can divide by 100. Once you divide by 100, you divide 1 by 100, and of course, you'll get 0.01 meters. And of course, one of the most important observations to make here is that in order to convert from centimeters to millimeters, you need to multiply by 10. And to convert from millimeters to centimeters, you need to divide by 10. You convert from meters to centimeters, you multiply by 100. Whereas to convert from centimeter to meter, you divide by 100. And of course, I've got work here which I want us to do. Convert the following. This is your homework, which I want us to look. Convert 5 square centimeters to square millimeters. So you need to change centimeters to millimeters. So if you have got 5 square centimeters, how would you change that to square millimeters? And the second one, convert 20 square millimeters to square centimeters this time. Then the next one, of course, will be to convert 5 square meters to square centimeters. The next one will be converting from 20 square centimeters to square meters. And this will be homework that you can do to convert, and then we can look at that in our next lesson. And before we close, I just want to remind you once again that we have spoken now about the polygons, the regular polygons and irregular polygons, and we have looked at the perimeter of both polygons, where you add all the sides together to calculate the perimeter. But at the same time, we also looked at a wide range of examples where we were able to look at the regular polygons in an example like this one here, and of course the previous one, which is an irregular polygon. And then equally, we finalized our lesson today with using and converting between the appropriate units, which we are probably going to use a lot in the study of polygons. And of course, the activity that we have just done now. How many millimeters make up 1 centimeter is very important. How many centimeters make up 1 millimeter, and so on. How many meters? And I've shown you really that how to convert from centimeter to millimeter. Remember, the millimeters are one. Like if you take, for example, your ruler there, you'll be able to see that 1 centimeter is equal to 10 millimeters. So if you are converting from a centimeter to a millimeter, you have to multiply by 10, because 1 centimeter is equal to 10 millimeters. And of course, to convert from millimeters to centimeters, you divide by 10. The same example, if you've got 10 millimeters there, or if you've got 1 centimeter, then you can divide it by 10 to go to, if you've got 10 millimeters, sorry, you can divide it by 10 to get 1 centimeter. So from millimeter to centimeter, divide by 10. From meter to centimeter, multiply by 100. And of course, let's get our last comment from Bunolo. Bunolo, please come. Bunolo? Turn off your music, Bunolo. Right, I'm going to mute Bunolo now as we carry on now to say this is the homework that I want us to look at. And lastly, visit all the necessary sites that we need to visit in order to look at the various shapes, especially those that we have spoken about today. And let me also take this opportunity to invite you to our next lesson where we will carry on with various properties of 2D shapes. And of course, for more information, my details are there on the screen. You can reach me out on 082 623 2148. 082 623 2148. Alternatively, my email address there, makaneta.hm@gmail.com. And we are also in our social media pages, Twitter account @Africa Team Geeks. Same goes for Facebook, just search for Africa Team Geeks. And of course, this is the Lockdown eSchool, which is sponsored by the Sasol Foundation in partnership with the STEM champions. And of course, with also Africa Team Geeks, as well as the Department of Basic Education and MS Zora there. We really want to thank them for making these lessons possible on a daily basis. From me, once again, I want to thank you very much indeed for taking the time and the trouble to be part of this lesson today. Until we meet next week, have a good weekend. Thank you very much indeed.